Hi, ladies and gentlemen. Welcome to Griffith Observatory's Perseverance stream. We are here to bring you live our coverage of today's landing. And with me, of course, is Patrick So from Griffith Observatory, All Space Considered fame. I don't think we got to see him wave there, maybe. But in any case, we're going to tell you a little bit about today's mission, about how it got there, the steps that it's going to go through to reach the surface. And I'm going to tell you a little bit about what's going to happen on the surface. And then we're going to go live to the NASA coverage and we'll hang out with you. We'll comment a little bit about some of the things that you might not understand, any of the things that might be a little bit confusing. But mostly we'll watch the excitement together with you. We'll maybe answer some questions from chat and just have a good time with this landing. It's super exciting. So Patrick, I know you are ready to tell us how Perseverance got to Mars. What exactly happened to get to Mars?
That's right. So, all right. Well, let's begin right at the beginning with the launch, which happened in July of last year, of the Perseverance spacecraft, and this is the position of the Earth and Mars at launch. And then we fast forward to today, where the Perseverance lander is just about to actually make its entry, descent, and landing on Mars. And you can see that the Earth is actually moved further away from Mars. And that distance is 127 million miles, which means a signal from the spacecraft would take 11 minutes and 22 seconds to be received at Earth. So all the times that we're going to give you for the entry, landing, and descent, or EDL, will be Earth receive time. So everything would have happened 11 minutes and 22 seconds ago. Just a quick look at the spacecraft here is to scale. And inside this spacecraft, we have various components from the cruise stage that provides power to the spacecraft while it's in space, and the back shield and also the heat shield, which protects the valuable cargo, which is the descent stage or sky crane, and of course the Perseverance rover. Now, the most critical part of the mission will be happening very soon. And this is when the first part of the cruise stage, the actual cruise stage, will separate from the rest of the spacecraft. And that will happen at 12:38. And that's the time that we will receive a confirmation signal. And that will go to JPL and they will announce that, and we'll all watch that together, because each stage of this entry, landing, and descent is all automatic, and the controllers will not have any information other than the signals they receive that each of these stages of the entry has actually happened. At 12:48, the spacecraft will plunge through the atmosphere of Mars, and its heat shield will get as hot as 2,300 degrees Fahrenheit, or about 1,300 degrees Celsius. It's moving very quickly, around about 12,500 miles per hour. And the atmosphere will slow it down by 99%, so that by the time the parachute opens, the spacecraft will be moving about 900 miles per hour. That parachute is actually a supersonic parachute, and the diameter of it is as large as the Samuel Ocean Planetarium dome. So just to give you an idea, it's roughly about 70 feet across. The heat shield will separate, and then there'll be downward facing cameras that will take pictures of the terrain. This is a new piece of technology called terrain relative navigation, where pictures taken by the cameras will be compared with a orbital picture that's stored in the computer memory. And this enables the spacecraft to calculate exactly where it is relative to the ground, which is very important because there's a huge mountain range just to the west of the crater where it's going to be landing. Finally, the back shell separates the parachutes, and the back shell are deposited somewhere on Mars, and the descent stage will carry the rover down to a safe landing spot. And hopefully at 12:55, we'll get a signal plus or minus 30 minutes, depending on the entry, descent, and landing of the actual landing. And that will be the momentous moment when we know that the Mars rover has safely landed on Mars. Just a quick overview of this whole descent landing. This is the most riskiest part of the mission, and it's all autonomous. Starting with the spacecraft 10 minutes from above the surface of Mars and down to 0. So 10 minutes from 12,500 miles per hour to 0. That's quite a feat. The landing area is known as Jezero Crater, and you can see it has a very tight landing ellipse. And that's because of the onboard technology that enables us to land more precisely than other missions. You can see the landing ellipses of other missions, such as Curiosity, and the missions before were much larger. So we hope for a very precise landing and a area where it's the Curiosity rover the Perseverance rover can actually explore.
Well, thank you, Patrick.
Yep.
Yeah, that's very hopeful we'll be able to get to the ground down like that and have another rover on the surface like this. This, of course, is Curiosity with one of the famous selfies that it took. We had a couple of questions during your talk. Somebody wanted to know what the difference is between a regular parachute and a supersonic one. And can you talk about that quickly?
Yeah, the supersonic parachute, by the time that opens, the spacecraft is moving at 900 miles per hour, and the speed of sound is 760 miles per hour. So they need a parachute that can open up and slow down the spacecraft significantly, moving at that supersonic speed. So that's the purpose of this supersonic parachute, which was also deployed when Curiosity landed in 2012.
Yeah, the whole key is it needs to be designed that it doesn't tear itself apart, essentially. At supersonic speeds, you need to be able to handle those stresses, and a normal parachute certainly can't. So, and will we get pictures today? We sure hope so. That's the plan, is the sort of the, I don't know, hazard cameras or navigation cameras. I think we're supposed to get some pictures of those relatively quickly if they can relay them to us. Earth is going to be setting rather soon after it lands, but if they can relay some pictures to one of the orbiters and get the images back to us, we will see those. At least we hope. Do I have that right, Patrick?
That's correct, yeah. It would be from the Mars Reconnaissance Orbiter will be overhead at the time of the landing.
Yeah. So that's the hope. It's what any scientist would do. You get to a new location, you take some pictures, make sure your feet are on the ground or your wheels are on the ground, and then all is good to go. Speaking of ground, where are we going today? Well, we are going to Mars, obviously, but to Jezero Crater. And I realize we've Americanized the pronunciation on that a little bit, but bear with us. We'll get it right eventually. But we do appreciate all the comments we've received on that. Anyway, moving forward, we see here, there's the crater on the edge of the larger, what looks like a big bay off a sea. And really, 4.8 billion years ago, Mars is being put together. 3.8 billion years ago, you start to have oceans on Mars. So it was wet. It had water. Curiosity proved that, and proved that it was habitable. It was water that you and I could have drank and that life maybe could have formed in. But now we need to go looking for that evidence of life. And here's Jezero Crater, and you can see a couple of places where water has flowed into the crater and then it can flow out. In the upper left, you can see what looks like a river coming into it. Indeed, that probably was at one point a very rapidly flowing river. The landing ellipse is there in black. Moving along, you can see this is an Earth delta where rivers are flowing into a bay of sorts or a body of water, and you can see all that material being deposited. Well, that's why we're going to that location. That's why we're sending Perseverance there to go look at those deposits. In fact, NASA made a pretty great video I'm going to run for you now. We're going to take a look at what they said. It's a cool fly around of the landing site, so we hope you enjoy.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high and are the rim of Jezero Crater. The goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero Crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we'll use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero Crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
So that video made by JPL, thank you so much, JPL and NASA, for making all those materials available for us and the public to use freely, of course. It's all public domain. A little bit about this, you can see the color-coded imagery on the left, coded by chemicals that are there, by the signatures left behind of different types of rocks. And on the right-hand side, a little map made from that, or a similar one. Now, why are we going there? It's that regional carbonate and the carbonate basin fill. The carbonates are really good at holding on to signatures of life. As you can see here, a quote from one of the team members, carbonates are really good at preserving evidence for life. So if you had to pick a place on Mars to go to search for life, you'd go to carbonate inner ring of a shallow lake environment, which is exactly what is offered here at Jezero. That's why we're going there. It's amazing. It's a perfect environment to go searching for the evidence of life. Now, how are we going to do that? Well, an international team of engineers built the instruments that are on board Perseverance. And let's take a quick look at them here. I'm not going to go into too much detail, but the ones I'm most excited about, honestly, are the Super Cam up on top. It's a high resolution camera. Mastcam Z will take stereo pictures. We're going to be able to put on our stereo, our 3D glasses and get stereo images there. It has a video camera. It has, anyway, lots of amazing stuff. And indeed, also it has a laser spectrometer. So it's going to be able to vaporize material with a laser and measure what it's made out of, which is extra cool. Also, it has a little instrument to make oxygen, believe it or not, on the surface of Mars. Why are we doing that? Well, to see if we can. We need to know if it works very well if we're ever going to send humans there. We need to make oxygen. Out at the front end on the arm, you can see Sherlock and Watson. Well, those are the instruments that are most likely to see the evidence that life was on the surface. So very, very exciting. Lots of cameras on board, lots of instruments, and we're going to Mars to look for evidence of life. Now, what if we see the chemical signatures of life? Is that good enough? Probably not. There are going to be arguments over whether you could make that signature under other conditions on Mars. So we're not stopping there. They are going to what's called cache samples, place samples of the most interesting locations, the things that are most promising to have signs of life left in them, put them in this container and hold them. And they're hoping in the 2030s, NASA will go back, pick up those samples. They'll be good to go, send them back to Earth, put them in a lab and actually look in detail to see whether there's maybe fossilized microbes in there. It could be. Anyway, very, very soon, we're going to have a new rover on Mars, but that's not all. In this picture, there are two spacecraft, well, two landers that have gone there. The one on the ground is called Ingenuity. It piggybacked along with, or piggy-bellied, as I like to say, since it was carried on Perseverance's belly, all the way to Mars with the rover, and it's going to be dropped on the surface, and indeed it's going to fly. It'll fly in about 90-second intervals. It'll do little hops, probably do about 5 of them to test if this technology works or not. The blades are about a 4-foot diameter, which is off my camera screen. So it's not a super small helicopter, but it is a test mission. This is to go see if this technology works. If it works well, maybe we'll see bigger helicopters in the future. One other minor change in Perseverance that I like to talk about is the wheels. This is a wheel of Curiosity back in 2017. You can see damaged by the rocks, and that zigzag pattern evidently was grabbing onto the rocks, and if it couldn't quite lift itself, some of the rocks would puncture right through the material, the aluminum. I took a tour of JPL and got to pick up one of the wheels that they had on the test version of Curiosity. It's very light. It's not hard to hold those at all, but much larger than you think it might be. When you see the pictures of the rovers, a lot of people picture little tiny rover wheels. No, they're this, nearly car tire size. They're very big, and Perseverances will be that size too. So in the very near future, we have a rover that will be on Mars doing more experiments, more interesting work. One of the experiments I didn't mention yet is actually the ground penetrating radar. So in this picture, I imagine the radar shooting down 30 feet into the surface of Mars down below and maybe picking up, I don't know, something that's buried down in there that's interesting. Could there be a layer that shows that there was a big flood in the past that flooded that region? Or could we look for climatic changes in Mars's climate over the years? So a lot of research can be done by penetrating down into the surface. It'll be very interesting to see. So Patrick, how are we doing on our trip to Mars? Are we almost there? How are things looking?
Yeah, we're going to go and take a look at a computer-generated simulation showing the Mars spacecraft, Perseverance. So Matthew, could you go ahead and switch to that view? That's perfect. So this is NASA's Mars Eyes on the Solar System, and you can see right there in the background is Mars, and it's only got a few less than 1,000 miles to go before it reaches the surface. The Mars Perseverance spacecraft has slow rotation. What you see there that's showing is the solar panels on the cruise stage, which provides power to the rest of the spacecraft. And right now, the readout is that it's only about 7,000 miles from Mars, and actually not 7,000 miles, just 7,000 miles per hour. It's moving towards Mars, and so this speed will increase as Mars's gravitational influence increases and pulls the spacecraft in. So we're about 5 minutes from the first signal that will be received at JPL, and that will be the confirmation of the separation of the cruise stage, which is that solar panel stage that you see that's attached to the spacecraft. So why don't we go ahead and go to NASA Live, and let's watch together and listen for the confirmations of the signals as the spacecraft begins its entry, descent, and landing.
Yeah, in fact, the site we were looking at with the animation, Patrick, what was that? We had a question in the chat asking where someone could look at that.
The site?
Yeah, was that Eyes on the Solar System?
That was Eyes on the Solar System. It's a special site. If you type in Mars Perseverance Live, you can get to a site where it has a link to that site. Okay, we're now seeing live images from JPL's mission control room for Mars Perseverance.
Some very intense faces.
To more easily cut the line
right
in
now,
upcoming cruise stage separation, which is under 4 minutes now.
about 4 minutes, but I couldn't catch that.
We have now enabled the rover pyro bus.
That's the pyrotechnic system that's
We
going
are
to
powering off the cruise stage devices.
and these are the things in the cruise stage that we no longer need. With the pyrotechnic system working, we can explode the devices.
The vehicle is preparing for the upcoming cruise stage operation in about 3 minutes 15 seconds by powering off all the devices on the cruise stage in order that they can be safe once the cruise stage is jettisoned.
Yeah, this cruise stage has been very reliable.
We are firing our first pyros to vent the HRS liquid and gas.
This has been the coolant that's kept their vehicle from getting too hot on the way to Mars. We have to vent it into space. And this is one of the first major events that take place as part of entry, descent, landing.
The HRS vent anchor is complete.
Yes.
We will see the next anchor in approximately 3 minutes.
Okay.
We are currently 12.5 minutes from entry interface. We are coming upon cruise stage separation in 2 minutes and 20 seconds.
What's happening now, Rob?
Okay, well, we're just waiting. The rover is completely in charge. It's doing all the things we've taught it how to do. It's all built into the software. We've tested it over and over and over again. This team has spent 24 hours a day, 7 days a week, testing this thing for years. And so this is really the culmination of all that work. So this vehicle is getting ready to push that cruise stage away. Once it gets pushed away, the entry system with the rover inside, with the rover still in charge, is going to get ready to take the vehicle, turn it to the right orientation, and aim it to Mars, and prepare for entering the atmosphere. This won't be long. Be prepared for this event.
We're about a minute and a half from
so folks, we're almost at the point that's going to happen. Patrick, if folks are looking at Eyes on the Solar System, will they see an animation of the cruise stage separation?
Okay, so
Yes,
about 10 minutes for
everything
cruise
should be
separation
live,
till it
and
enters the
and
atmosphere.
everything
We'll
is
vent out and out
in
things
Earth
happen.
receive time. So when the separation happens, they should have a signal, a confirmation of the separation of the cruise stage.
Has switched to broadcasting tones. These tones are received directly from Perseverance, but have very limited information content. We won't receive real-time information until about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. We are under a minute from cruise stage separation, about 10.5 minutes from entry interface.
It's getting exciting. I have to admit, I am quite anxious, but very hopeful that this machine is going to do what we asked it to do.
We're seeing the heartbeat tones.
Okay, that means that there's no more ones and zeros coming. It's just the vehicle telling us it's still alive.
We're continuing to receive tones from Perseverance, standing by for cruise stage separation.
There it goes.
Look at that.
We have indication that cruise stage separation has been confirmed by the spacecraft.
Well, the craft thinks it's separated. That's a good sign.
In about 1 minute, Perseverance's landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
Okay,
So
so now the
9
vehicle's on
minutes
its own.
before-
It's turning itself into the direction of facing the heat shield toward Mars, and will eventually hitting the top of the atmosphere. We're not far away. This is going to go very quickly from here on out.
Very quickly. Now, you might notice the jar of peanuts that's there in the control room. This has become tradition at JPL, and good luck. I don't have time to tell the whole story now, but that's why you're seeing it's a good thing.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance masses that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We're about 7.5 minutes from entry interface.
So what you heard there was that the spacecraft has indeed turned to entry attitude. What that means is the field is facing Mars. Very important.
Doing their job. And now we've spun down from the 2 revolutions per minute that the vehicle had the whole way to Mars. It was a spin-stabilized spacecraft. And then from here on out, it's going to just be a bullet, and it's going to control its orientation and attitude via rockets on the back of that backshell.
Points carrier lock. Sorry, DTE from Radio Science from Green Bank reports carrier lock. You see the carrier on the downlink.
More good news. The Deep Space Network in Green Bank, where we have a big radio dish, has picked up the radio signal and is locked on.
We're about
That's
6
good.
minutes and 45 seconds from entry interface. We have confirmation from Greenback that they are receiving direct-to-Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report. This is as expected. We're currently just over 6 minutes from entry interface.
Can you imagine that, being that close to Mars, entering 6 minutes, you got nothing significant to report? How about Mars is right there?
While we wait.
This is amazing. And again, the folks at JPL have to remain calm right now. They have work to do. I don't really have to be calm. I'm nervous. I don't know about you folks. This is exciting. Patrick, how are you feeling?
This is, yeah, I'm pretty nervous right now because everything is autonomous right now. So all the software.
5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
Camera reports the electro radio is powered on, ready to receive signals from the lander.
Okay. MRO is ready and able and waiting for to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight Local 1
from entry interface.
We don't need these 1 to 0s, as Swati said, but to land safely, but we really need it for our own health and well-being today, to keep our nerves under control. But
around this time, a second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
Okay.
And so you
Very
have those
soon
two
we'll be getting 1s and 0s,
spacecraft,
from our
Mars
radio on the
Reconnaissance
rover.
Orbiter and MAVEN will be receiving signals from Perseverance spacecraft.
Now, Patrick, the
entry interface is
orbiter
nothing more
Hope
than just
did
an
arrive
arbitrary
safely
place in
at
the sky
Mars.
that we've defined to be
So
above the atmosphere.
spacecraft that
From
have all
that
been
point on,
heading
there's
sort of in a
definitely,
convoy there. One is already in orbit, but that won't be
There
helping.
We are 2 minutes from entry interface. Perseverance is to transmit heartbeat tones, indicating everything is nominal.
Nominal is a good word, everyone. If you're new to
So
any
the
of the
tones
NASA
can tell us
broadcasts,
whether
nominal
something's
means
bad or not is
everything
happening. So
we're
far
going
the
according
heartbeat
to plan.
is doing well. So the vehicle thinks it's in good shape to land, which is a great sign.
Just over 2 minutes left before atmospheric entry.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry.
One of the reasons Mars is difficult to land on. You end up going quite quickly, and there's a very thin atmosphere to slow you down.
And we're seeing Ao Chen, who's the lead entry descent
We are
landing.
1 minute from entry interface.
Starting to see nervous looks on some of the faces there in their eyes.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
About seconds from entry interface. 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars.
Here's where things start to get warm.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
Confirmation, I'm sure, is based upon the fact that the spacecraft has started to slow down.
The spacecraft is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
I believe they said they're experiencing a blackout now.
MRO has lost lock.
Yep, they've lost lock. That's due to the superheated Martian atmosphere around the spacecraft. The radio signals can't penetrate it and get back to Earth. But as soon as it slows down enough,
these are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes.
you'd weigh 10 times what you would weigh on Earth if you were on Perseverance.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
.1252 is the next milestone for the parachute deploy.
Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Parachute confirmation here soon. Question in the chat, you wouldn't weigh 10 times what you weigh on Mars, but only if you were on the rover decelerating. It's slowing down so much you'd feel that weight. It's like hitting your brakes in a car. You feel like you're pushed forward.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO's reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes, yes, yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
All right. There's that supersonic parachute.
Yes.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Keep that in mind. People skydive from those sorts of altitudes all the time. That's pretty low, in fact. So we are really close to being on Mars at this point.
Yes, yes, yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface of Mars.
This is all good.
Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
That's huge, right there.
We have timing of the
Knows where it
landing
is.
engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the backshell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Now we are getting the reports from Mars. So all of this happened 11 whatever minutes ago.
Our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct Earth tones.
As expected. As expected.
As
Sky crane
expected.
maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
Signals from MRO mean
Beautiful confirmation of landing.
Perseverance safely.
Yes!
On the surface
Yes!
of Mars.
All right.
To begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance
Perfect.
is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
So the rover's currently talking to the orbiter, and the orbiter is talking back to us. Communication was barely lost through all of that, which is nuts. That's completely insane that JPL and NASA are able to pull this off and be communicating this soon. This is a huge achievement.
Oh,
MRO reports
Yeah,
they're
this-
still getting telemetry from the lander.
All right, all stations.
we got it. We're
Touchdown
there.
confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
Yeah, stay tuned. We're hoping for some very preliminary pictures. Wheels on ground. Now, I want to thank you. Now we have over 400 viewers with us right now. So thanks for coming to Griffith Observatory to enjoy this experience with us. It's phenomenal to have you all with us today.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not.
It's a really thrilling moment.
Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
Getting to Mars is really difficult, and the United States, NASA, JPL continue to do it
MRO is still seeing a strong signal from
remarkably.
the lander.
Make it look easy. They really do. It's amazing.
Yeah, my hat's off to the JPL team. They're the best in the world.
Yeah.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Keep in mind, these images are small.
OL3, I have the target point on the map when you are ready. We are ready, OL3. Go for it.
Where'd they hit? Where did Percy land?
Hopefully right next to the Delta.
I hope so. I can't wait for the first
Flight,
pictures.
I'll be moving in, showing you the safe zone that we've landed in.
With the hazard cam, perfect. Just beautiful.
The team has just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
So how am I going to get any work done the rest of the day?
You can see the shadow of the rover.
Shadow of the rover, those flat rocks that are indicative of being on the bottom of a lake for a while. They look like lake bed rocks to me. Things could be washed down. This is a phenomenal achievement. This location is just perfect for the science. We have a real shot of learning about whether Mars had life in the past, really starting to pick apart that question.
In the next few days, we'll hopefully be seeing some of the images of the parachute opening. There's actually cameras pointed up in that direction, and we'll experience the whole entry, descent, and landing with images. And even we can even hear it. There are microphones on the spacecraft and also on the rover itself that can listen to the sounds of Mars.
I'm hoping we get video and audio of the helicopter flying. That would be very fun from a distance to have Perseverance take images of that happen. Really
We've got our second image in. Our second image is in.
Okay, these we have a camera in the front and out rear of the spacecraft.
Oh, secret NASA information there.
They're near the ground, so these are pretty close. You can see the wheels there. And they're a little dirty because we've got glass covers over these cameras, but we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago, just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.
Socially distant fist bumps.
Joining us now is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
How does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and just a credit to the team. I mean, just what an amazing team. To work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission. But if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions. And then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade, and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions, or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith. And then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And
yeah, now's a good time for anybody on our stream. If you'd like to type into the chat any questions you have, we're happy to answer questions on our stream on our YouTube.
Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes. Hi, Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the commanding team will be working overnight while the rover is asleep so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks. So it'll be exciting and some late nights, but we're also excited and we can't wait.
It's a whole new lifestyle.
Yes.
Yeah, do we want to go away from that? Or people seem to think it was cute, though.
This is Sophia's video.
Hi, my name is Sophia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
Well, Sophia, Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well, thanks for your time, Jessica, and good luck living on Mars time.
Thank you. Should be fun.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to be here. You can see all my mask markings on.
Well, you were just celebrating, and rightly so. Now, you've been around for a number of Mars landings. What makes this one special?
Well, you know, two things. I mean, it's the biggest and best rover we've ever sent to Mars, and it can really, you know, do amazing things in terms of, you know, its own scientific exploration of this habitable environment, you know, at Jezero. But, you know, it's also, as you've heard today, you know, it's the first step in Mars sample return. So really, you know, it's not only doing its own mission, it's setting us up for a series of missions and to bring those samples back. And, you know, a lot of the effort to develop the rover was specifically designed, you know, for that sampling and caching system. It's one of the most complex robotic systems ever made. And, you know, having it down safely means Mars sample return continues right on course, and we are moving forward.
Wonderful. Now, JPL has a long history with robotic space exploration. Why do you think it's so important to continue to push those boundaries?
You know, there's a lot of reasons. I mean, obviously, you know, for places that are far away, like Mars, and even farther away, you know, like Europa, right now, robotic exploration is the only way we can make these scientific discoveries and really understand these early habitable environments. In the case of Europa, maybe it's even still habitable. And, you know, we're not ready to go there with astronauts yet, but the robots are ready to go there. And so we always, you know, are forerunners and pathfinders of human exploration. And we start by sending, you know, our eyes and arms there in the form of a robot. And it is just fantastic to be able to do that and to learn from each rover, learn from the science and the engineering, and make the next one better and make more and more discoveries. And every time we do one of these missions, we make fabulous discoveries. And you know, each one is more exciting than the last.
Yeah, completely true, ladies and gentlemen.
Now, as
Dr. David
director of
Reitzel here from
JPL,
Griffith Observatory breaking in. We're going to bring you some more of our coverage about the mission now that we know we have successfully landed on Mars. So why don't we go ahead and switch to one of our views? Do we still have eyes on the solar system? Does it show the surface of Mars now? I'm just curious. As we're seeing the JPL shot there, and we're going to move over here to our tab, and we'll see what. Well, it shows the spacecraft out in space currently, but this is as of 12/11. So that's an hour ago. Maybe they're replaying the entry, which could be very interesting. We'll have to investigate that later. Anyway, I have, and I can share, the Twitter feed of Perseverance. The NASA Perseverance Mars rover has said hello to the world. And why don't we go ahead and share that if we can. I'm sharing my screen here. You can see, hello world, my first look at my forever home. So this is some good fun here. The first picture from the Perseverance Mars rover on the surface of Mars there from the Twitter account at NASA Persevere. So I recommend everybody follow Perseverance. You can keep up with it. And keep in mind, you can see the dust on that image on the cover. There's glass blocking that view that hasn't been ejected yet. Those dust covers will be ejected. They will go on to have much higher quality. This is a navigation camera, really used just to drive the rover around. So those high resolution stereo images, they replaced the lower 2 megapixel cameras with 20 megapixel cameras. I had that info wrong last night, actually. And so we are going to get some ridiculously high resolution images of Mars. They will look great on your high def displays. There'll be stereo, there's going to be video, and we're just going to get more and more of this. So again, follow the NASA Perseverance Mars rover on Twitter and interact and have some fun. But don't forget to follow us at All Space Considered. If you ditch all the vowels in considered, you can follow us on Twitter and we'll keep you up to date. And don't forget also to follow Griffith Observatory on Twitter, Facebook, and other social media. And I want to give a special comment and thank you to our support group, Friends of the Observatory. In fact, photo members, Friends of the Observatory members last night got a special treat where we told you more in depth about the mission. I told you all about the instruments. Patrick told you what to expect today, what would happen, all the different steps we saw. So if you were a member, you got a special treat last night, and members get that. They get benefits, and we highly recommend that you join our support group, Friends of the Observatory. In fact, if I could ask some of our moderators to find that link to join Friends of the Observatory and go ahead and put it in the YouTube chat. I believe it's already there in the information for you, but if it's not there, we'll put it in the chat. You can join, and you can come, and once we reopen, you can come see a program in the Samuel Ocean Planetarium, see one of our other features in the Leonard Nimoy Event Horizon Theater, enjoy our galleries. come to Griffith Observatory when we reopen. It'll be fantastic. But for us to be able to do that, we need our support group, Friends of the Observatory. So thank you, Photo, for all you do. Thank you, all the Photo members, for making this sort of programming possible for free, and the sort of stuff we did last night for members that was extra special. We'll have more of that coming. So Patrick, you know, these first images from the ground are really fantastic. When are we expecting to get more? Are they going to release more pictures today? You said Earth was going to be setting. What's the plan? Do you know?
Yeah, so as you heard during the landing, the rover was actually sending signals to the Mars Reconnaissance Orbiter. So some of the live pictures were actually relayed from that particular orbiter. Also, some more extensive engineering data, such as the EDL footage that we'll hopefully see over the weekend, has been sent to another orbiter called MAVEN. That spacecraft software actually is not quite comparable to the kind of signals that was sent from the rover, and also from the entry descent phase. So they will need some time to process the signal before it's sent back to Earth, and that will be a delay of maybe a few days. But we can get some immediate signals from the rover once the Earth rises tomorrow morning above Mars, that is.
Well, fantastic. Now, is there any way we could see what it would look like at Mars? Like, is there some way that perhaps you could show our viewers what night on the surface of Mars might look like for Perseverance tonight?
Yes, of course. I'm gonna go to back to my
yeah,
slides.
Patrick there. He knew it was coming, but indeed, you know, of course, Patrick likes to do our sky report at All Space Considered and does a fantastic job of it, telling everybody what to look up for the month, to go look out at night. Where can you find Mars? Where can you find various planets? So Patrick took it upon himself to give you a special treat. We provided this for our members last night. We decided to give you a little taste of it today as well. So Patrick, what are folks gonna, or what is our rover going to be able to experience?
All right. Well, the rover actually landed roughly about late afternoon, roughly about 3:50, I think, Mars time. So the sun was still up. The Mars, Earth had set, but it's going to experience its first night on Mars. And so in the early morning on tomorrow, early morning, just an hour before sunrise, you can see where, looking to the east there's a little blue glow there. Sunrises and sunsets are bluish on Mars. That's the sun is only not too far below the horizon, but just a little bit off towards the south of east. You can see the Earth. The Earth will rise just about 1 hour before the sun rises from the location of the rover. That's what you will see if you're actually on Mars and looking at the early morning sky. One of the interesting things about Mars is that Mars's north pole in the sky is not where the North Star is. You can see right at the top there's the Big Dipper, and that's pointed to a star called Polaris, which is the star that at the Earth's north pole of the sky. But the north pole of the Martian sky at this location, which is only 18 degrees north of the equator, is actually located way down here, well below Polaris. And the nearest star to the north pole of the Martian sky is called Deneb in the constellation of Cygnus the Swan. So throughout the night, Deneb would actually revolve around the polar region of the sky of Mars, and actually will not set from that location. It would be the star will be actually a circumpolar star, which means it will never set and just simply circle around that position of the north pole of the sky.
It looks like Vega is almost circumpolar, but not quite. We'd probably need to be another 5 or 10 degrees north.
That's correct, yeah. And just so everyone knows that the you can actually find your latitude by the altitude of the North Pole of the sky. So here on Earth, if here in Los Angeles, we're about 34 degrees north of the equator. So if you were to go out and look for Polaris and measure its altitude, you find out it's the same number of degrees as your latitude, which is 34 degrees above the horizon. This means that from the location of Jezero crater, which is only 18 degrees north of the equator, that means that position above the horizon is 18 degrees above the Martian surface. As you look around, you can see some of the familiar stars of the actual spring sky. The Earth is in the constellation of Libra, the scales, just for context. And if you were on the surface of Mars looking around, you can find all of these constellations, which are the same constellations that we can see here on Earth. So if you're a future stargazer looking at from the surface of Mars into the night sky will be ablaze with many faint stars. The skies on Mars are much darker than any sky here on Earth. And basically because it's devoid of light pollution. And also Mars has an atmosphere which is only 1% as dense as the Earth. So you're literally seeing the equivalent of the night sky from an altitude here on Earth of 100,000 feet above the surface.
Well, interesting stuff, Patrick. I'm seeing we had a question in our chat. Maybe our moderator answered it, but nonetheless, Caddy, who's 6 years old, wanted to know, will Perseverance the rover find history on Mars? And you are exactly correct, Gaddy. That is the whole point of going. We're sending a rover there to go look into the ancient history on Mars. We're talking 3.5 to 3.8 billion years ago. And in fact, some of the rocks up on the rim of the crater, if it works its way up there, could be more than 4 billion years old. You know, that's older than even the oldest people that are alive on Earth, of course, Gaddy. So yeah, the rover is going to go investigate ancient history on Mars. Now, it's not history like we think of history on Earth, which is, you know, kings and queens and, you know, countries. It's the geologic history, or the history of the rocks, and the history of when was water there, when did the water come and go, and also the history of was there life. So yes, absolutely. We're hoping that it will reveal the history of the development of life on the planet, perhaps. It'll be a lot of work, but that's the whole point of going, is to go look for Martian history. Great question. So, you know, I'm looking forward to also weather reports coming from Perseverance. One of the instruments on board that we haven't covered in any detail, it has a little weather station on board. So in addition to measuring wind speed, temperatures, things like that, it'll be very, very interesting. Now, the temperature on Mars on a balmy day, we're talking below freezing generally. It's, you know, the rocks right at the very surface might get up around freezing on a lucky day where you happen to have some high pressure, but really you're talking in the negative hundreds of degrees most of the time. So very cold. Wind speeds will typically be a few miles per hour. And again, that atmosphere is very thin. But when you have two weather stations, we have one at InSight making weather measurements. You have another one, Curiosity, able to make some very basic measurements. And now we have Perseverance. So we're starting to get weather stations on Mars to get us a better picture of what's happening beyond the global pictures we get from orbit. What causes those dust storms to kick off? We think we know, we think we're starting to get a picture, but it would be really good to understand it in detail if we're ever going to send people. Those global dust storms will have to be contended with. So these tools we're sending are getting significantly better and better. It's really amazing what we're able to see. I'm going to take a look at the Twitter feed here again and see if we got anything else from Perseverance yet. And if we had that landing ellipse, if it shows where Perseverance landed. I'm curious to see how close to the center of the target they managed to land.
And David, you mentioned the freezing temperatures on the surface of Mars. In fact, the Mars helicopter, has as it actually derives its energy from solar panels, and 2/3 of that energy will actually be used for keeping the helicopter warm at night. And then the other third of the energy is just used for flight. The helicopter will only fly roughly about 90 seconds. And the plan is that for the first 30 days of the surface mission, there would be about 5 flights on a helicopter. Also, the rover has an RTG, which is like a thermal generator, which provides power to the rover. But it also has Freon that runs through tubes to keep the rover and all the electronics warm, because in order for them to function properly, they need to be kept at a certain temperature, and freezing temperatures will cause it not to function.
Yeah, it would be a real problem. So much of the energy just goes to keeping spacecraft warm. We're getting near the end of our stream time here. We're supposed to sign off at 1:30. Should we roll the 2-minute version of the 7 Minutes of Terror video just to remind folks what Perseverance went through today? We can take a look at that, and then we'll have a final couple of minutes to answer any of your questions that you have before we sign off on today's stream. But it's been really exciting. I have to say, I was super tense in those moments as Perseverance was coming down. You see the folks at NASA, they had simultaneously looked confident, but also sort of, you have that, I don't know, the worried look, but the confidence that they know they can do it, but waiting for those confirmations as they come through, because the rover was really very much running on its own at that point and doing it on its own. Yeah, I'm curious, do we have that video in the PowerPoint? I'm not sure I'm seeing it. I'm seeing a final slide there. Is that it, Patrick? If not, I'm sure we can queue it up.
Yeah, let me click on it and see. We should have it queued up there. Oh, it appears that we don't have it.
Yeah, it is moving. I think this is it. So if we can get sound on that, that would be terrific if it's there. It's running, ladies and gentlemen. It just starts out with a dramatic black frame, and it brought up the date there for us, and you see Mars getting closer. So let's enjoy these 2.5 minutes of terror, really. So, ladies and gentlemen, that was the shortened version. That whole thing took about 10 minutes from the point it hit the top of the atmosphere, 7 minutes of terror where you lose the signal coming down landing. And like Patrick said earlier, there were microphones on board. We're hoping to hear some of those wind noises and the sounds. That information is being sent back to Earth in the next days or week or so. Who knows how long it'll take to process, but we'll bring it to you via our Twitter feed. We'll bring you more information at All Space Considered, of course. It's just a really remarkably amazing day just to be an Earthling, you know, let alone an American. It's a great day for the entire human race here on Earth. Patrick, what are your final thoughts here today?
I mean, first of all, it's nerve-wracking. I'm really relieved that the lander is on the ground and ready to do its scientific mission and bring us some really fantastic results that we have never seen before. And it is another great success for NASA and JPL, and hopefully we'll go forward together and learn more about the planet Mars.
Yeah, absolutely. So everybody, be sure check out that donation link that's in the information for our YouTube stream. Friends of the Observatory made this possible. When we reopen, come visit us, come to Griffith Observatory, see all our wonderful facilities, look through our telescope, visit the Samuel Oschin Planetarium. But again, visit us at All Space Considered as well. We do a program every first Friday of the month. It's free, open to the public. It's on YouTube. Patrick and I and Chris Butler and guests will come bring you all the fun information. We're hoping to have a special guest from NASA to talk Perseverance, and we'll have a special guest from Friends of the Observatory to talk about the exciting future about being one of our members and the benefits and some changes that are coming. And you can hear about all of that at the March All Space Considered. Thank you for joining us today. We appreciate all of you. It was great fun, very exciting, and we'll see you at a future event. Thank you so much, everybody.